This is our introduction to exercise 18G on applications of anti-differentiation kinematics on page 655 of your textbook. As per usual, we're going to start today's lesson with a do now question. I've included the question and the answer on the right hand side to see if you got the right answer. I want you to pause the video, I want you to do the question, and then we'll get started. Okay, so a particle moves in a straight line. We're quite familiar with this basis. So that its position, SM, is s meters, is relative to O, or the origin, at the time t seconds, where t is greater than or equal to 0, and it's given by the formula there. Now, normally we use x of t conventionally, which we discussed last lesson, but what we're going to be doing is going to be using s of t because it's the same as x of t, but in this situation they're provided as s, so we'll use s. The question's asking for the initial velocity of the particle. Remember, initial means that we're referring to when t equals to 0 or when time is 0. And so then I'm going to go ahead and apply that. So before I do that, I'm going to write out the equation just for simplicity's sake. So t cubed plus 5t minus 8. We're going to derive it because we're looking for the velocity, aren't we? So to find the velocity, we have to derive the equation. Remember that last lesson we looked at the idea of if I have position and then I have my velocity, I have to derive it in order to get my velocity there. And then in order to get my acceleration, I derive it again. Okay, so this time we're looking for our velocity. So I'm going to go ahead and write v of t, which is the same as s dash t. So the derived version of our s equation. I get 3t squared plus 5. Remember, the negative 8 disappears because it's a constant. And so we end up with that. I'm going to go ahead and substitute v of 0, which gives us an equation of, or a value of, 3 times 0 squared plus 5, and therefore 5. And so the velocity of the particle isn't 5, it's 5 meters. So I'm going to write v of 0 equals to 5 meters a second, because it specifies meters and seconds. Alright, awesome. So today's content is pretty much the same as last lesson's content. The only difference is obviously we're anti-differentiating instead of differentiating. So we looked at this idea last lesson, and what I want to say is that it's exactly the same if we go opposite. So for example, to get from acceleration to our velocity, we anti-differentiate that. And to get from velocity to our position, once again we anti-differentiate that. So keep that in mind as we move forward. The first question specifies that a body starts from 0 or O and moves in a straight line. To clarify, it just means a particle body or something of its sort. It doesn't mean a literal body. After t seconds, t is greater than or equal to 0, remember that, keep that in mind. Its velocity v meters a second is given by the equation v equals to 2t minus 4. The question in part A specifies that we need to find the position in terms of x. Okay, position, in terms of t. In this situation, we can go ahead and use our x of t. Now we know x of t is equal to, if I can move the screen, there we go, is equal to the derived version, so not derived, the integrated version of vt, so the anti-differentiated. So I'm going to go ahead and do that. So instead of writing 2t minus 4, I'm going to anti-differentiate it based on our rules that we learned over the last few weeks. So that's 2 times t squared over 2. Minus 4 times t to the power of 1 over 1. And we also write a plus c. Simplifying that, we get t squared minus 4t plus c. And from there, I'm thinking to myself, well, I'm looking for its position in terms of t. Perfect, that's it. Now, I actually have to find the value of c in order to get an actual equation for the position. So what I can do is I can read the question. It says it starts from O. Okay, it starts from O, which means that it starts at a position 0. So when time is 0, we know that our position is 0 as well. Okay, so based off that, I'm going to go ahead and substitute those values in. X of 0 equals to 0, or in other words, 0 squared minus 4 times 0 plus c. Therefore, c equals to 0. And then I can write x of t equals to t squared minus 4t. Continuing on, I have to find its position after 3 seconds. So I'm going to go ahead and write that out. So position after 3 seconds, I'm going to write x of 3. Let's just substitute that into the equation. I get 9, or 3 squared I should write. 3 squared minus 4 times 3 Okay, and then from there I get -3. Now we don't write -3 because that's not a position. We have to include units, we have to include context. So in this situation, I write therefore position at t equals to 3 seconds is, oops, let's write that a bit neater, seconds is 3 meters left of origin. Okay, pretty straightforward. Last part of this question, I need to go ahead and find the distance traveled. This question is a little bit more tricky. Keep in mind that we've got this equation for our position, and we've got this equation up here for our velocity. Now, the easy way to do this is, well, partially incorrect way of doing this, is just saying, well, I know that it starts off at, when x equals 0, I have a value of 0 because it starts at origin, so that point there, and then it goes to -3 and ends there. Okay, because I know after 3 seconds it goes to -3, but that would be a very simplistic and actually incorrect perspective. We have to consider, what if it goes, for example, what if it goes like this, or maybe it goes like this, right? In both situations, they both end up at -3, but we have to find, or rather, how can we find if that's true? So what we do is we find v. Remember that v equals to this equation that's highlighted on top, 2t minus 4. And I can let that equal to 0. Let v equal to 0. And I get t equals to, well, actually, let's do the math out together. So 2t minus 4 equals to 0. And we get t equals 2. Add 4 on both sides, divided by 2. T equals to 2. Which means that when time is at 2 seconds, I know that it stops. Okay, it stops and maybe changes direction, maybe continues. We don't know yet. So let's go ahead and find that value there. Okay, so I'm going to go ahead and find, we know that t equals 2. When I put t equals 2 into the original, into the position equation, which is the one right here, we end up with, so x of 2 gives me a value of -4, which means that if I was to get rid of this over here, and I was to draw out a proper scale here, 0, -1, -2, -3, -4, what actually happened is that it started off at 0, went down to -4, right? That's after 2 seconds, and then after that went back to -3. And so I can safely say that from 0 to -4, that's 4 meters, and then from 4 to -3, that's 1 meter. And so the final answer is, for the distance traveled, so distance equals to 5 meters. Okay, bit of a tricky one to get wrap your head around, but hopefully that makes sense. Alright, last one over here, example 2. A stone is projected vertically upwards from the top of a 20-meter high building with an initial velocity of 15 meters squared. I do want to give context and say that this question is extremely new in the sense that you have to make sure you understand what the different terms mean. In this case, I'm reading this bottom over here. In this case, we only consider the stone's motion in a vertical direction, so we can treat it as a motion in a straight line. Also, we would assume that the acceleration due to gravity is approximately -10 meters per second squared. Note that downwards is considered a negative direction. So for this question, it's quite a lot of steps. The first thing I want to do is try and find an equation, because there's no equation given to us. So we have to find the time taken to the stone, blah, 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 but we have to find the equation. So to do that, let's take apart what information we have. I know that the acceleration is -10 meters per second squared. So I'm going to write that down. A equals to -10 meters per second squared. What else do I know? I know there's an initial velocity of 15 meters squared. Remember that initial means when time equals to 0. So v0 equals to 15 meters squared. And I know that it starts at the top of a 20-meter building. So a 20-meter high building. So that also tells me that x of 0, x of 0 is equal to 20 meters. Because it's 20 meters, it starts at that point, so that's the position. Okay, based on that, we can actually create our equation. So I'm going to go ahead and do this in different colors so we can see. Okay, so I know that acceleration is negative 10 meters a second. I know that I can rewrite that, because remember, if I anti-differentiate my acceleration equation, I get my velocity, don't I? And anti-differentiating my acceleration of negative 10 gives me v of t equals to negative 10t over 1 plus c. Now I'm going to get rid of the over 1 because you guys know that doesn't matter anyway. So we end up with this, negative 10, t plus c. I'm going to go ahead and substitute what I know. Remember that when t equals 0, my velocity is 15. So I can write v of 0 equals to negative 10 times 0 plus c equals to 15. From there, I know that c equals to 15. And therefore, my velocity is equal to negative 10t plus 15. Okay. Finally, in order to get our final position equation, we anti-differentiate it again, and we get x of t equals to, I'm going to anti-differentiate this equation, so that's negative 10t squared over 2 plus 15t over 1 plus, now just for consistency's sake, I'm not going to write c, you can write d or e, whatever it is, I'm going to write c1. From there, I'm going to substitute my final point over here, final bit of information. I know that when my time is 0, then my position is 20 meters. So I write x of 0 equals to, and I'm going to simplify that, negative 5 bracket 0 squared. Actually, you know what? I'm going to simplify it first, and then we'll write it out. So x of t equals to negative 5t squared plus 15t plus c1. Now let's substitute our t equals 0, so x of 0, let's rewrite that a bit better, equals to, that's 0, 0, so we end up with c, c1, because they all cancel out and give us 0 anyway. And then I get equals to 20, and therefore our equation is x of t equals to negative 5t squared plus 15t plus 20. And that's our position equation. The rest from here is pretty straightforward. So question A tells us find the time taken for the stone to reach its maximum height. You guys already know stuff like this. What I'm going to do is I'm going to copy this part over here so that we can just write it on top and keep it there. So I'm going to move it up here. There we go. So find the time it takes for the stone to reach its maximum height. Remember, to find the maximum height, we have to find our stationary point. And to find a stationary point, we find our differential equation. In this situation, I know that my velocity is negative 10t plus 15. And if I let my vt equal to 0 to find my turning point, or my point of inflection, in this case it's a turning point, we know because it's a parabola, we get v of t equals to 0, and we get t equals to 15, not 15, sorry, 1.5, having solved that. And that's 1.5 seconds. Alright, easy. Alright, part B. Part B asks us to find the height, there we go. Find the maximum height reached by the stone. In this situation, because we know it's a negative parabola, it's going to have a sad face shape. And so at that point, we have to find what is my y value, or rather my maximum height. So I substitute that in, but into the original equation of the position, not the velocity. So v of 1.5 equals 2, and sorry, there we go. X of 1.5 equals 2, and you'd write negative 5 bracket 1.5 squared plus 15 bracket 1.5 plus 20, which simplifies to 31.25 meters. Okay. Finally, part C asks us to find, there you go, what the time is taken for the stone to reach the ground. And in that situation, we know that x has to equal 0 because the position or the height of it is going to be 0. So I'm going to write x of t equals to 0, and we have to solve it. Now remember, x of t is the equation up above, so I'm going to write negative 5t squared plus 15t plus 20 equals 0. And in order to simplify that, I'm going to go ahead and divide everything by negative 5. I get t squared minus 3t plus 4, minus 4 equals to 0. I can use cross method. I know that I can use negative 4 and positive 1. And I get t minus 4, t minus 1. That should be plus 1 equals to 0. And we end up with t equals to negative 1 or 4. Now we know that t has to be greater than or equal to 1. We can't have negative time, and so the final answer for that part is 4 seconds. And then finally for part D, I'm going to go ahead and go back to the question so we can read it together. The velocity of the stone as it hits the ground. Now that's pretty straightforward as well. As it hits the ground, remember we're saying, well, when does it hit the ground? When time is 4, or rather time is 4 seconds. And so we're trying to find what is my velocity when time is 4. We end up with negative 40 plus 15. That's just from simplifying and substituting the value into this equation right here. And then from that we get negative 25 meters squared. And that's it. Hopefully that helps clarify some information. Get started on exercise 18G. And then when we're back at school, we'll go through some revision together. Good luck.